Okay, question 2 is about energy transfers and cars going down ramps and speeds and velocities and possibly accelerations. I can't quite remember. So a student lifts, work please pen, a toy car from a bench. Is this recording? Yes. And places it at the top of the slope. Describe an energy transfer that occurs when the student lifts the car from the bench. So there is a hand. With some pretty chunky fingers, but they've lifted that car up and just got the basic idea that they're going to use their chemical energy, transfer it to kinetic energy and moving it upwards, and then when they leave it on the top of there, it'll have some stored gravitational potential energy. So just make sure you only ever stick to our memory method with our help to suck magnets, and then person transfers chemical energy to kinetic energy. The kinetic energy is then transferred to the gravitational potential energy stores of the car at the top of the ramp. Done. Nice, easy question. The student lets the car roll down the slope. Describe the experiment to measure the speed. Interesting. At the bottom of the slope. So my tip would be, I'd even do a little drawing to show the examiner that you've spotted that. So I'm going to get rid of my dodgy hand there. Bye-bye, dodgy hand. Get rid of all of that. And we can see, well, what do we need to do? We need to have a specific distance that we're going to measure there. We know our shoot Donald Trump. I'm changing that for next year. I don't want to upset him. And then we can measure that distance, and we're going to talk about we need a ruler for that. So the next part is I'm going to need a stop clock, because we know speed equals distance divided by time. So I've got my stop clock. I've got that. We're going to let it move down, and then we're just going to put that together, measure the distance with a ruler, measure the time it takes to travel that distance with the stop clock, and use shoot Donald Trump. So speed equals distance over time. You could also have done the thing where we get a known distance for an interrupt card, and we could have used 2 light gates connected to a data logger. I'll put DL, being lazy. Even that DL looks ropey. And I could connect that to a data logger. So the answer for that one then, and I'd suggest you add a little drawing to it. It helps you with it. So we know speed equals distance divided by time. Use a ruler to mark a distance at the bottom of the slope. You could add it in there, 50 centimeters or whatever you want to pick. Use a stop clock to measure the time taken to travel that distance. And then that's it done. Or we could say add a known length of card, or add a known length of an interrupt card to the car. Use light gates and a data logger to measure the time. Speed equals distance divided by time. That bit gets missed out because the students forget that they need to say it. Okay, student needs to develop the experiment to determine the loss in potential energy. So we know when we let go of the car, it's going to go from GPE to KE. And then you'd use your formula book. You'd go and look it up, and we know that's MGH. We know this is half mv squared, so we've just got to talk about what we need. So to determine it, I need the mass times the gravity times height. Well, we know that number's 10, or 9.81. So clearly I need the mass. And remember, we've got to say we need, if we go back to this drawing, apologies guys, it has to be, oh my God, it has to be the vertical height. All right, we want the vertical height. I don't want that distance there, so we need the vertical height. So, sorry, get rid of all of that. Well, we know GP equals mgh, so we need the mass of the car using a digital balance. And just always get in the habit of saying what the equipment is that you need to do it. And the vertical height of the car with a ruler. Done. If you wanted to, we could add in there kinetic energy equals half mv squared, and therefore I'd need the mass and I'd need the velocity at the bottom. When the car rolls down the slope, some energy is transferred. So we've got GPE go into kinetic energy and some thermal energy. This is the total input. That's the useful output. And this is the wasted energy. So we just know that the total energy divided by the useful energy, not divided by, take away the useful energy will equal the wasted energy. So thermal energy equals the GP, take away the KE. So you can see, well, we know the input. We know that the input equals the useful output plus any wasted energy. So to find this out, move that to that side. Wasted equals total input minus useful output. There we go. And I've just said that in a different way. That's it, done.